Or something we've never seen before? Webb's data hints at strange possibilities: magnetic disturbances, voids in plasma, and asymmetrical material falling back toward the center instead of escaping. Some researchers now wonder if we're seeing the formation of a new type of stellar remnant, something between a neutron star and a black hole. A transitional object, theorized but never observed until now. With Betelgeuse just 642 light-years away, many ask, is Earth in danger? The answer is no, not directly. The supernova's radiation won't reach us with enough force to harm life here. But the effects may still ripple across the cosmos. Energy waves from the explosion could disturb interstellar dust, shift the behavior of neighboring star systems, and change how light travels to us from distant parts of the universe. Webb is now monitoring the spread of that radiation, tracking how our galactic environment responds. We may be safe, but our perspective of the universe could change forever. Betelgeuse is massive, ancient, radiant, and it is ending. This isn't just the death of a star. It's a cosmic mirror, reflecting back the truth that even stars must die. But in their death, new matter is born. From these ashes, new stars will rise, new planets will form, and the seeds of future life will scatter through the galaxy. This is not destruction. It's renewal, on a scale beyond human imagination. And we were fortunate enough to witness it. Within the massive cloud of data captured by Webb, scientists discovered something unexpected. The explosion of Betelgeuse is releasing rare elements like technetium and yttrium, formed only in the universe's most extreme conditions. Why does this matter? Because by studying these elements, we can trace the chemical journey of matter through the galaxy, from collapsing stars, to drifting dust, to the atoms in our own bodies. Webb hasn't just recorded an explosion. It's deciphering the code of creation. And Betelgeuse, even in death, is telling a story that began before Earth was born. Betelgeuse will never shine again. Its place in Orion will become a glowing remnant, an expanding cloud of gas and light. But its legacy endures. A legacy of knowledge. A legacy of elements. A legacy of perspective. It reminds us that even the brightest stars are temporary. Even the sun will one day fade. Yet from these endings come new beginnings. Without supernovae, there are no planets, no oceans, no life. Thanks to the James Webb Space Telescope, we now see that cycle in its full beauty, from collapse to creation. Out in the silent dark, 642 light-years away, a star has ended its life. Not quietly, but with a blaze of fury and light that has echoed through space for centuries. And thanks to Webb, we didn't just witness it, we understood it. We saw the signs, the collapse, the ignition, not as myth, not as legend, but as truth. Betelgeuse didn't vanish in silence. It left us answers, to questions as old as humanity. Where do the elements come from? How do stars live and die? What will become of our own sun? In that final burst of red light, Webb captured more than a death. It captured our origin story, and offered a glimpse into what lies ahead. Now the question remains, what else is the universe ready to reveal? And are we truly ready to understand it? Because this isn't the end. It's the beginning of everything that follows, after the stars. For many years, astronomers have watched one of the most brilliant and puzzling stars in our night sky. Betelgeuse, a red supergiant teetering on the brink of collapse. They knew the end was coming. They just didn't know when. Now, the James Webb Space Telescope has captured something once thought impossible. The precise moment Betelgeuse began to explode. A stellar death. A cosmic eruption. A glimpse into the raw, unfiltered power of the universe itself. This isn't just another astronomical discovery. This is the closest supernova ever recorded by humanity, a one-time event that changes everything we thought we understood. Betelgeuse, found at the shoulder of the Orion constellation, is no ordinary star. It is a red supergiant, more than 700 times wider than our Sun, and nearly 20 times more massive. For decades, scientists knew it was unstable, its surface swelling, dimming, surging with eruptions. Then in 2019, it dramatically faded, setting off global speculation. Was this it? Was the star finally going supernova? Now, with the unmatched sensitivity of the James Webb Space Telescope, we know more. What's unfolding is far more complex and more astonishing. For the first time, we're observing the real-time collapse of a star, gigantic energy bursts, turbulent plasma flows, and magnetic fields spiraling into disorder. Betelgeuse isn't just dying. It's undergoing a violent transformation right before our eyes. The James Webb Space Telescope has spent months watching Betelgeuse with its deep infrared vision, seeing beyond what any telescope has seen before. And now, the findings are in, and they're extraordinary. Convective bubbles the size of Jupiter are bursting on the star's surface. Superheated gas is streaming outward at unimaginable speeds. And within the spectrum of light, there's evidence of a powerful shock wave moving through the star's outer layers. For the first time in human history, astronomers are watching the physics of a star ripping itself apart, not in simulation, but in reality. And it's happening just 642 light-years from Earth. Unlike the countless supernovae that erupt in distant galaxies, Betelgeuse is close. Close enough that its explosion may eventually shine brighter than the full moon, visible even in daytime skies. But more than a spectacle, this is a once-in-a-generation opportunity to study how a star dies, how its core collapses, how heavy elements like carbon and oxygen are formed, how shock waves shape the surrounding space. What Webb is observing is more than the end of a star, it's the birth of the ingredients for life itself. This is our cosmic history unraveling in reverse. The death of Betelgeuse reveals the deeper cycles of the universe. Through Webb's detailed imaging, scientists can now model the final stages of stellar evolution with new precision. We're not just witnessing a supernova, we're unlocking the process that forges the building blocks of planets, oceans, and biology. This knowledge may even allow us to predict other stars' fates long before they reach their end. It's not just science. It's revelation. A moment when humanity peered into the blackness, and the blackness answered with light. The explosion isn't just a visual event. It sends shockwaves across space, disturbing everything in its path. Already, Webb has detected the early ripples, high-energy particles surging outward, superheating nearby gas clouds, distorting the star's halo of dust. And there's more, possibly gravitational waves from the core's collapse. If confirmed,